Let me start the topic Fraunhofer diffraction at double slit. To explain the double slit, let me consider two slits. Here the slit are AB and CD. We consider two slits AB and CD. This is the length. We use this lens to converge the incident rays coming from the sources on the screen. Y dash be the screen, and this is the center point on the screen. All the lights are coming from these two slits this way, and they are converged at point P naught due to the lens. This is because we are studying here Fraunhofer diffraction, and in the case of Fraunhofer diffraction, the distance between the slit and the screen is effectively infinite. Effectively infinite. Here, let me consider the slit width is D, and the difference between these two slits, slit AB and CD, is B. Here, this is D and this one is B. This is the diagram for the two slits. These two slits work as an individual sources. These two slits, the slits AB and CD, work as an individual sources, and these are just like a coherent source. When a plane wavefront fall normal on the slit, all the secondary wavefront travel in the direction of OP. When the plane wavefront reach on the slit, then all the secondary wavefront travel in the direction of P naught at the center point of the principal axis on the screen. Central point. Hence, P correspond to central bright maxima. This is the central point, so this point is central bright maxima. central bright maxima. Now, due to the individual slits, a resultant amplitude of all the secondary waves diffract in the direction of theta. Here, this is the slit. This is the same diagram as drawn in the previous slide. Now, now my aim is to find out the position of maxima and minima on the either sides of this central maxima. This is the central point, and here we have a lens L2 dash is the lens, and our aim is to find out the position of the maxima and minima at point P, which is just above the central maxima. Then these rays are coming from these two slits. This is the O. From these two slits, they are diffracted with an angle theta.
Sir, screen negative.
Here we have two slits. These are AB and CD. Here a screen Y, Y dash, and this is the principal axis, and P naught is the central maxima. Now our aim is to find out the position of maxima and minima at point P. The incident rays are reaching at point P through the lens with a diffraction angle theta. This is the angle with the principal axis theta, and now let me find out the path difference of rays reaching at point P from point A to point C, and this is the slit width. This one is the difference between these two slits. To find the path difference, let me draw a perpendicular from A to C dash. Perpendicular, this is C dash is N. Just make an angle theta with the slit. And the rays are reaching at point P from these two individual sources. Let According to the single slit, this individual source produce diffraction due to the angle theta at point P, and the rays are coming from this as a primary waves, and after that they are a secondary wavefronts. And according to the single slit experiment, in that experiment we considered in this ray, this slit is divided into a number of slits. After that we solve this in a combination of the set of rays, set of slits. By on that concept, the resultant amplitude for the individual slit is equal to r a naught sine alpha divided by alpha, where alpha is equal to pi d sine theta divided by lambda. This is the result which we are using from the single slit diffraction. Now, for the simplicity, all the secondary waves may be taken as a single wave of the amplitude, and that amplitude is R, single wave amplitude. Single wave amplitude. The resultant at point P on the screen will be the result of interference between the two waves of same amplitude started starts from S1 and S2, and that will be equal to this R, this is, and uh, to explain the maxima and minima at point P, we need the path difference from the sources S1 and S2. We need path difference from the sources S1 and S2, and that path difference is this one, Cn, from the triangle A, from the triangle ACN. We can get the path difference from the triangle CAN. Then Cn is equal to B plus D sine theta, and therefore the phase differences therefore the phase difference is denoted with delta is equal to 2 pi, as we know that, is equal to path difference, and this delta is equal to 2 pi by lambda into B plus D sine theta. The resultant amplitude at point P will be given as resultant amplitude at point P on the screen will be given as the resultant of the two sources. This is from source number 1 and R2 from source number 2. Then the resultant amplitude is Rs square is equal to R1 square plus R2 square plus 2R1 R2 cos delta. Here the angle difference is delta. Let me put the values of this R1 and R2. As we know that these two sources are similar in wavelength and amplitude, then R1 is equal to R2 is equal to R is equal to E naught sine alpha divided by alpha. Let me put this value in this equation. Then we have E naught square sine square alpha divided by alpha square plus E naught square sine square alpha divided by alpha square plus 2 E naught sine alpha divided by sine alpha E naught sine alpha divided by sorry here this is alpha only, and here again alpha in the multiplication in cos delta. Some of the terms are common in this equation. That is, now the equation will become this divided by alpha square is equal to 1 plus cos delta, because 1 plus cos delta is equal to twice cos square delta by 2 from the sine formula. Then this is equal to 4 E naught square sine square alpha divided by alpha square cos square delta by 2. This is equal to the square of resultant amplitude, and let delta by 2 is equal to beta, and which is equal to pi lambda by b plus d sine theta. where B plus D is called grating amplitude, grating element. This B plus D is grating element. Then the resultant amplitude at point P is equal to 4 E naught square sine square alpha divided by alpha square cos square beta. And as we know that the intensity is equal to the resultant square. So intensity at point P is equal to this R square is equal to 4 E naught square sine square alpha divided by alpha square cos square beta. Here from this expression it is clear that the resultant intensity depends on two factors, on two factors. One is E naught sine square alpha divided by alpha square, and the second factor is cos square beta. Let me discuss these two terms one by one. The first term, E naught sine square alpha divided by alpha square is due to the diffraction. Diffraction, and the direction of the minima are given by this term r of the minimas are depend on alpha, and this alpha is equal to plus minus n pi, as we discussed in the article diffraction through single slit. Here we have put let me put the value of the alpha. The alpha is equal to d sine theta divided by lambda is equal to plus minus n pi. From this, d sine theta is equal to plus minus n lambda. Here the value of n will gives the value of minimas. N is 1, 2, 3 and so on for minima in case of diffraction. Here the value of n is equal to 0 is not allowed, because it will generate an indeterminate form. So in this equation, the value of n is equal to 0 is not allowed. Here the value are start from n is 1, 2, 3 and so on. And the position for the second maxima approaches to from this diffraction terms, the position of maxima, or we can say secondary maxima approaches to for the values alpha is plus minus 3 pi by 2 plus minus 5 pi by 2 plus minus 7 pi by 2 and so on. The intensity of the maximas will decreases continuously according to the terms increases like this. This is the same expression as we discussed in the case of single slit. Let me discuss about the second term. The second term is cos square beta. This term is due to the interference pattern. Interference pattern because in this case we are studying the diffraction due to two slits, and when we have two slits then we get a interference pattern also, and these two sources are initiated from the single sources. So the source are highly coherent and produce a interference pattern. Now let me discuss about the interference pattern at point P due to the two slits. The term corresponding to the interference of the two diffraction pattern coming out from the two slits. These terms give a set of, by this term we get the set of dark and bright fringes in the direction of the maxima are given by the direction of maxima are given by cos square beta is equal to 1, and this value is equal to 1 for beta is equal to plus minus m pi, and this beta is equal to pi by lambda b plus t sin theta. And this is possible for the values of m is equal to 0, 1, 2, 3 and so on, and we get the secondary maximas with equal width. Thus Thus in the direction of theta is equal to 0, we get the central maxima. Central maxima. And at this point, both at this point means point P naught, both interference and diffraction interference and diffraction coincide. Now let me discuss about the minima for by the interference pattern. The minima due to the interference term is given by
सर जो सेंटर पे फ्रिंज
the minimum due to the interference term is given by cos square beta is equal to 0, and this value is 0 for plus minus 2p plus 1 pi by 2, and this value gives the is equal to sin theta is equal to plus minus 2p plus 1 lambda by 2. And the pattern from the double slit Fraunhofer diffraction through double slit is, this is the central point, and like this is the diffraction pattern due to the individual slits, and in between these we have in between we have maximas and minimas